Welcome to ICND2 Lab 11, Access List 2. This is the second of two video labs that discuss access lists. For those of you using the Cisco Pressbooks, note that the ICND2 Exam Certification Guide Chapter 6 covers the concepts that are also shown in this video. This lab has three main objectives. By the end of this lab, you should be better able to explain how discarding packets that are sent by a server towards a client prevents the client from talking to the server. You should also know how to configure ACLs that match well-known ports as the source port in a particular packet, and you'll be reminded how to see counters for an ACL that shows how many packets have matched each line of the ACL. This video lab uses a single scenario step. In this one step, we'll see how to filter packets that are coming from a server farm and going towards a set of clients. The lab topology used for this video is the same as with Lab 10. In this case, we've got a couple of clients that sit on the left side of the network and two servers that sit on the right. This simple network has three subnets that you see here. Subnet 172.16.10 on the left, 172.16.2.0 in the middle, and 172.16.3.0 on the right. Note that in each case a /24 mask is used just to keep things simple. So to demonstrate how to filter packets that are going from a server back toward the client, let's take a look at the first of three different criteria that will be used for the access list in this lab. First of all, we want to permit PC1 in particular to use web services to connect to a server farm on the right. So if you consider the packet that goes left to right from the client to the server, the source IP address, of course, will be 172.16.1.1, which is PC1's IP address, and the destination IP address will be any IP address in subnet 3. Also in the TCP header, we'll note that the source port will be some number greater than 1023 because PC1 as a client will use a dynamically allocated port number, and the destination port will be the well-known port used for web services, or 80. Note that the dynamically allocated port numbers start at 1024 and go up from there, but because the access list command can only use the greater than operator and not the greater than and equal to operator, the examples in this video always show greater than 1023 in the actual access list commands. Now, comparing that packet to packets sent from the server farm back toward PC1, the packet sent by the server farm, of course, will have the opposite IP addresses and the opposite TCP port numbers. For instance, the source IP address will be from subnet 3, and the destination IP address will be 172.16.1.1. Similarly, the source port number will be 80, and the destination port number will be the port that PC1 had chosen, some dynamically allocatable port that's greater than 1023. Next, let's take a look at the second criteria for the access list in this lab. In the second criteria, we want to be able to telnet from clients on the subnet on the left to telnet servers in the subnet on the right. So we don't care about a specific IP address, but all IP addresses in subnet 1. So the source IP address of a packet sent from a client on the left toward the server farm will be from subnet 1, and the destination address will be 172.16.3. something. In other words, it's in subnet 3. Similarly, any client on the left will allocate a port of 1024 or greater as the source port and send the packet to destination well-known port 23, which is the well-known port for telnet services. So to filter packets sent from the server farm back to the telnet clients, consider those packets now with opposite IP addresses and opposite port numbers. A packet sent from one of the telnet servers then would have a source IP address in subnet 3 and a destination IP address in subnet 1, and similarly it would have a source port of 23, the well-known port for telnet, and a destination port greater than 1023. So that's the hard part. Finally, the third criteria for this access list is to deny all other traffic. So let's turn our attention to the command line interface and see how to configure this ACL on router R2. The command line interface part of this lab focuses on router R2. The reason for that is that in order to match the port numbers, we need to use extended IP access lists. The best location for extended IP access lists are as close to the source of the packet as possible, and of course in this lab we're trying to filter packets sent by the server farm. So we're going to end up applying this access list inbound on R2's LAN interface, so we'll configure the ACL there on router R2. So let's take a look at the first access list command. Here we see access list 101, permit because we want to allow the traffic, and then let me just get the rest of it typed in here. Alright, now that we see the access list command there, let's examine it. First of all, the first meaningful parameter is TCP, meaning that this matches IP packets, specifically only those that also have a TCP header. Then if you look at the next few parameters there, 172.16.3.0 with a wildcard mask of 0.0.0.255 matches all packets whose source IP address begins with 172.16.3. Of course, those are the IP addresses in the subnet on the right where the server farm resides. Next, highlighted on the screen, you see the EQ/WWW. That refers to the source port number because the EQ follows the source IP address and wildcard mask. So that's checking the source port number of well-known port for World Wide Web, which of course is port 80. Next, the highlighted parameters that you see there, host 172.16.1.1 represents the destination IP address, specifically the IP address of PC1. Finally, the highlighted parameter GT1023, GT meaning greater than, means that the port number, the destination port number in this case, is greater than 1023. So this command should match for the first criteria that you saw, which specifically is allowing PC1 web access to the servers on the right. The second criteria that we need an access list command for is very similar to the first, the differences being that we care about the entire subnet on the left instead of a single host, and that the application is Telnet instead of World Wide Web. So if you give me a moment to type in this latest access list command, bear with me. Keep going here. Alright, there we go. So, if you first focus, we've got TCP, once again, all IP packets that also have a TCP header. The source IP address in this case lists 172.16.3.0 with the same mask, meaning source IP address from the same server farm subnet on the right. And then a source port of equal to Telnet. Of course, that's really port number 23, meaning the source port should be 23. Following that, you see the destination IP address and wildcard mask of 172.16.1.0 with a 0.0.0.255 wildcard mask, meaning any destination IP address in subnet 1, which happens to be on the left. Finally, the GT1023 parameter at the very end means the destination port must be greater than 1023, which is typical of a dynamically allocated port on the client. The third criteria says to deny all other traffic, so we could just not configure anything else in the access list and use the implied deny all at the end of the access list. However, so we can see the counter values show up, I'm going to go ahead and configure a deny all statement explicitly here. As you see here, deny IP any. Now as a quick review, that means all IP packets because of the IP keyword, any source address, any destination address. We need the IP, any, and any keywords, mainly because you have to configure at least those three parameters in any extended access list command. Now, as mentioned a few minutes ago, we're going to apply this access list on R2's FA00 interface. Let's get into FA00 interface configuration mode and use the IP access group 101N command, which tells us that R2 will filter incoming packets on its LAN interface with access list 101. Now for perspective, no traffic has been attempted between the clients and the server farm yet, so if we take a look at the show IP access list command briefly, we see the three explicitly configured statements there in access list 101, but we don't see any counters there at the far right hand side of the output for each line. Next, I'm going to go to a few of the clients on the left and ping, telnet, and connect with a web browser to several servers on the right. Now, I'm not going to show this in the video, but essentially I'm generating some traffic, some of which should be denied and some of which should be allowed. So now that I've generated some traffic, let's repeat that show IP access list command here on router R2. And if you look at the output, notice we've got some counters on the far right now. We see that we've had a few web packets, several more telnet packets, and some more that match the deny at the end. Note that it's important to explicitly configure that deny any at the end of the access list, otherwise we wouldn't have any idea of how many packets were denied by this particular access list. This concludes ICND2 Lab 11. In this lab, you've heard an explanation of how to discard packets sent by a server in order to prevent clients from connecting to those servers. You've seen how to configure access lists to match well-known ports as the source port number, and you've seen how to view counters that show you how many packets have matched each line in a particular access list. The counters are particularly important for both troubleshooting and for monitoring for security threats.